We will now expound upon principles of counting. So a man has 4 pants, 5 shirts and 8 hats. So then you can say the total number of ways this person can dress up is just the multiplication. 4 times 5 times 8. So there are 160 different ways in which a person can dress up. Now we can extend this above result to a general principle. So suppose there are m experiments and these experiments are performed. So each of these experiments has an outcome n1, n2, n3, n4, so on all the way to nm. So the experiments are 1, 2, 3, 4 all the way to m, and n1 to nm are the corresponding outcomes. So then the total number of outcomes which is possible for this experiment is n1 times n2 times n3 all the way to nm. So now we come to notion of factorial. So factorial is in how many ways can 4 people stand in a line. So that is an example which we want to generalize. So there are 4 people and there are 4 people will stand in 4 spots in a line. So there are 4 people. So when you start, you can fill the first place with 4 choices. Any of the 4 people you can put here. So the first position can be filled in 4 ways. So after you have put a person here, so once you have put a person here, then there are only 3 people remaining. So now out of these 3 people, you can put anyone in the second place. So once you fill this place, now only 2 people are remaining. So we can fill the second place with remaining 3 people. Now in the third place, there are only 2 people remaining. You can fill this place with 2 people. So once you fill this place up, there's only 1 person remaining, and this last person is assigned this place. So for the third place, we have only 2 people left, and therefore there are only 2 ways which are available to fill the position. And after you fill the third position, we have only 1 person left who is assigned the last position. So total number of ways is, you multiply them, 4 times 3 times 2 times 1, just like this case. You multiply the options, or you can say the number of experiments here. So first place is 4 ways, second place is 3 ways, 2 ways, 1 way. You multiply them, and that is what is called 4 factorial. That is 4 times 3 times 2 times 1. So if you actually multiply, you get 24. But the notation here is 4 factorial. That means you start from 4, then you subtract 1 from it, that is 3, subtract 1 from it, that is 2, subtract 1 from it, that is 1. So this is the notation for 4 factorial. That is, you multiply everything up to 4. Now we can generalize this 4 people standing in a line to n people standing in a line. And in that case, the total number of possibilities is n factorial. So n times n minus 1, n minus 2 all the way to 1. So the answer to the question was, in how many ways can 4 people stand in a line? The answer is 4 factorial, which you compute as 24. So in how many ways n people can stand in a line? The answer is n factorial, which is nothing but n times n minus 1 times n minus 2 all the way to 1. Now this factorial sometimes gets difficult to compute because it could be multiplication of large number of numbers. So for a large n, it can be shown that n factorial is approximately equal to n divided by e. Now e is nothing but exponential of 1. So this e is a constant, n divided by e raised to the power of n times square root of 2 pi n. So this is called Stirling's approximation. And this is very useful in case n is a large number. So for example, for 100 factorial, rather than multiplying everything, we can just simply use this formula to compute it.